You've probably heard of capsaicin before, and you've also probably heard of it being referred to as the literal spice molecule. If you imagine a Scoville scale where pure capsaicin is right at the top of that Scoville scale, something like a bell pepper, something not very spicy, even sweet perhaps, would be right at the bottom of the Scoville scale. Yet how on earth does such a normal sort of molecule and chemical cause such an insane reaction, adverse reaction to the body? When you eat a sort of spicy meal, you feel that sort of burning sensation, itching sensation. If you sort of mindfully, consciously focus on it, it feels so weird and odd for your sort of brain and central nervous system and conscience to actually sort of handle and understand. Even when you get capsaicin on your skin, you still feel that sort of itching and spice and burning on your actual skin. How exactly does capsaicin cause this? And that is exactly what I'm going to go through in today's video. How and the mechanisms of capsaicin, how it acts on the body's nervous system, as well as a few interesting things about potential benefits, about a few allergies and reactions that capsaicin can cause that are way, way, way worse. Any of the sort of spice feelings that you may feel when you sort of just eat a normal chili pepper, as well as how it is excreted and metabolized by the body during a few metabolic processes. So to start, we are going to discuss capsaicin's acute mechanisms on the body, which is essentially just what happens as it immediately comes into contact with the sort of human nervous system and human cells in general. Imagine you were eating a chili pepper, imagine you were eating some spices, some seasonings on a meal. You get that sort of burning feeling inside of your mouth. How exactly is that caused? And this burning sensation has something to do with sensory neurons. Now, a sensory neuron differs from a motor neuron. A motor neuron essentially is the thing that makes your arms move and react to certain things. The movement of someone's muscles is essentially based on their brain coordinating the movement of said muscle using motor neurons. However, a sensory neuron is when the muscle feels something that is sort of external, and this will send an impulse to the brain, and then the brain will maybe activate the motor neuron. For instance, if you touched a hot pan or something, your muscles, your nerves inside the tips of your fingers would feel that heat, and then your brain would sort of react and move it away. That is essentially how sensory and motor neurons work. And capsaicin acts and sort of confuses and manipulates the sensory neuron. And capsaicin acts on the sensory neuron membrane. It doesn't exactly act inside of the neuron itself, simply the membrane where sort of things can sort of diffuse and influx and outflux inside of the neuron membrane itself. Now, nerves and neurons are so abundant inside of the body. When you eat a chili pepper, when you eat something spicy, there are so many nerve endings on the sort of cells of your cheeks and your gums, your lips, your skin even. That's why when you have capsaicin on your fingers, on your skin, you still feel that burning and itching sensation, because the capsaicin can act on the nerves that are literally at the tip of your skin, but they are at such a small level that you cannot visually see them, nor can you almost really consciously and tangibly imagine them actually being there. But the way that often sensory neurons actually work is through ion influx and ion channels, allowing ions to either enter or exit the neuron itself. And this is often how sort of neuron impulses actually work. When you sort of touch that hot hob, something will happen to that neuron that means that things are going to happen to that neuron, that means that an impulse is then going to send to the brain. And capsaicin essentially means that when you touch that hot hob, capsaicin almost acts as if you've just eaten fire or heat or flame. That's essentially what capsaicin does. There is something on the membrane of the neuron known as a TRVP1 ion channel. Now, as I said, the ion channel means that cations, which are known as positive ions, can either influx or exit the membrane itself. And when capsaicin binds to this TRPV1 ion channel, these cations, mainly sodium and calcium, will enter the neuron at a very, very quick rate. And this will, the neuron will detect this. It's detected that the ion channel has opened, cations have influxed into the neuron, so it will send a signal to the brain, and your brain will sort of figure out that there is heat, because often cation influx into neurons through ion channels, through the membranes, sort of signals to the brain that there is some sort of heat sort of acting on your neurons. And so your brain will sort of send back to those muscles, to those sort of nerve endings where the sort of initial impulse, where the sort of initial capsaicin binding actually came from, and it will sort of send it back using the motor neurons, and it will tell your muscles and your cells to try to move away from that heat like you would if you sort of touched a hot hob. But the problem is that capsaicin isn't actually a hot hob, and you can't move away from it, especially if it's on the sort of inside of your mouth. And so it sort of manipulates, screws with your sensory neurons, and sort of betrays the sort of heat feeling, despite the fact that capsaicin doesn't actually damage your cells in any way. While you may sort of feel inflammation on your skin, on your sort of cheeks, etc., when you eat or come into contact with capsaicin, there isn't actually any cellular damage, any inflammation actually going on. Your body just thinks that there is some kind of heat there due to the things that capsaicin has done to the ion channels, and so it will send inflammatory substances to that sort of area. Then it will inflame for no particular reason, simply because it thinks there's some kind of heat there that it needs to sort of get rid of, even though there isn't, and so it will inflame. So many people think that capsaicin is like an actually hot chemical. They think that the chemical capsaicin itself is actually quite a hot substance, even though it isn't. It's just acting on the ion channel, causing cations to influx, which eventually means that it sends signals to the brain saying that there is some kind of heat right next to this neuron, and so it will send the signal back to sort of move away because there is heat. But obviously your body simply cannot do that because you can't move your cheek and gum cells away from capsaicin. And the reason that these cations can actually influx into the neuron membrane is through a process known as diffusion, and this occurs on so many different ion channels along the membrane. Because if you imagine there is one single ion membrane which may be made during protein synthesis or whatever, it's probably some kind of ion channel, even though it is made of protein. It's an incredibly small thing, even though in relation to all the molecules that are sort of existing inside of the images that I've been putting up on screen, it is an incredibly small thing still, and there will be absolutely thousands inside of every single, well, not really inside, but on the sort of membrane of every single neuron. And there are thousands, millions maybe, of neurons sort of interconnecting through your body, connecting through synapses, neurotransmitters, all that interesting stuff. So many of these ion channels exist, and that's why the sort of heat pain can feel quite concentrated. But that is also because there is not too many of these cations, these positive ions, Na+, Ca2+, inside of the cell. So when the ion channel actually opens up, it causes these cations to influx because there's so many outside of the cell membrane in the intracellular fluid that it will influx in, because heat is something that acts on this ion channel. I mean, I may have accidentally said before that the influx is actually the thing that causes the heat. I don't think that's necessarily too true, because as I've mentioned before with the sort of hot hob, a hot stove example, heat is something that actually opens up the ion channel as well as capsaicin. So when you touch the hot hob, the ion channel TRPV1 will open, and this means that the cations, sodium, calcium, will influx in. That will send a signal to the brain, because the movement of these ions will cause like an energy sort of difference from the outside of the cell to the inside of the cell. The cell can sort of detect that so many ions have influxed into its sort of intracellular fluid, and this will send signals to the brain, go through all the synapses, neurotransmitters, and that will end up meaning that because the brain thinks that there was some kind of heat there, it will sort of appear to itself that the heat is there and that your muscles should actually be moving away, as I've explained earlier. But while I mentioned before that capsaicin doesn't actually damage any cell tissue, doesn't actually cause any inflammation, it isn't actually a hot molecule in and of itself. It can cause long-term acute damage to nervous cells when it's sort of abused in large quantities. You can become quite desensitized to the hot pain that capsaicin causes if you're consuming this stuff for like an extended period of time at quite a high dosage. They're the two requirements: high dosage, long time, and your cells, these neurons and these neuron membranes, these ion channels, will become desensitized to this constant influx of sodium and calcium ions mainly into the ion channels. Either the ion channels just don't open up as much, they don't respond to capsaicin as much as they did before. Because imagine the first time that you ever ate a chili pepper. This foreign capsaicin molecule that your body may have not ever experienced before in large quantities is suddenly everywhere. It's binding to every single ion channel, opening up every single ion channel. When you have this stuff over an extended period of time, your ion channels are used to this sort of stuff. It's like, yeah, we're supposed to kind of respond to heat and all that, but now this capsaicin thing it's kind of getting boring now. We're not really going to open up our ion channel itself as much as we normally do when we sort of first came across this foreign substance. So less sodium and calcium ions in flux, less sort of concentration of heat, less sort of urgency of inflammation is sort of sent to the brain. Your brain will still sort of make itself think that there is some kind of heat there, and so heat will sort of appear there, but it's not going to be as much because there wasn't as much ion influx as what it previously was the first time that you may have potentially eaten a chili pepper. And this can also translate to other things. While heat often acts as a stimulant for the ion channel TRPV1 to open, there are other things, loads and loads of other things that can act as a stimulant to open this thing. And some of those things, including heat itself, will be affected to open the ion channel, because capsaicin just does a desensitization effect to the ion channel. So even when you touch a hot hob after you've had loads of capsaicin, while it will have 10 times more sort of influx than capsaicin itself after you've been desensitized to that particular thing, that there will still be a little bit of desensitization to that sort of heat. Now there's other things like pain and stuff, actual like pain. Imagine you were being punched in the shoulder, you had a dead leg. That's a different kind of pain. That's not the type of pain that capsaicin produces. That is probably a different sort of ion channel, a different sort of sensory neuron membrane, motor neuron sort of membrane ion channel thingy that is responsible for all those different kinds of pains and different kinds of sensations and feelings. But this specific one, this sort of heat, this burning, this itching, that is TRPV1, and capsaicin will desensitize you to that sort of feeling in general if you sort of overuse and abuse capsaicin for an extended period of time. But as well as potentially having some long-term acute effects when used and abused in high dosages over an extended period of time, it can also have some seemingly quite guru woo-woo weight loss benefits in a way, which I did some research on and I thought I'd relay to you as well, while kind of on the topic of the things that capsaicin does to the body. Now, there are a few things that capsaicin does to the body. It can fasten your metabolism. I assume this is due to the sort of things that it does to the ion channel, maybe a few separate things that it actually does to the body that isn't due to the ion channel, which is specific to what causes the sort of burning and itching sensation. But I assume that maybe the constant influx of capsaicin, the constant things that capsaicin is doing to that ion channel, just fastens your metabolism in a way. And if you don't really know how exactly a faster metabolism is going to aid weight loss, a faster metabolism means that you are burning more calories passively than what you were when your metabolism was slower. The reactions, your glycolysis, your Krebs cycles, your oxidative phosphorylations are all happening at a much quicker rate compared to what they were previously. And this means that you end up losing weight quicker, because these processes are the things that burn calories. They burn calories, they take up energy. And so that will sort of take away stuff from the diet that you may be having. And then that means that you can achieve your weight loss goals potentially quicker if you maybe just added a little bit more spice to the diet, maybe in the form of things like peppercorns, maybe if you, not like incredibly hot chilies, but a few mild chilies, some jalapenos, that sort of stuff. Maybe that could potentially aid with weight loss in one way or another. As well as this, during its metabolism, which I'm going to get to later on in the video, it is an alkaline forming substance, and I reckon this is because it forms an OH group onto its sort of baseline molecule, which I'm going to talk about during the metabolism. That means that it can stop gastric secretion from the stomach, it can stop stomach ulcers, it can stop stomach cancer. And while this is all sort of stuff that I did on a few research from actual professional medical sites, I myself am not a professional medical doctor, so take my sort of advice with a pinch of salt. Treat me like I am kind of like a weight loss guru, woo-woo, in this sort of medicinal department, because that is essentially what I am. That is my level of education in this sort of stuff, because now I'm going to get onto something known as a capsaicin allergy, which is something that should be taken very, very seriously if you have it, and which is why that you shouldn't just go out of your way to take loads of capsaicin in the form of things like peppercorns and chili peppers, because capsaicin can cause allergic reactions in some people, which can be very serious, lead to fatal sort of anaphylaxis shocks, and so much more pretty bad stuff, which is why you should probably, if you are considering taking capsaicin and you don't really know if you're allergic to it or not, you've never really had that many chilies, etc. in your sort of diet before, it is worth speaking to an actual medicinal professional that's not myself, because I can't actually give you the sort of allergic reaction tests. But capsaicin does essentially cause an allergic reaction. An allergic reaction is essentially an autoimmune response where your body attacks almost itself. You may have heard of autoimmune diseases where the body attacks its own sort of cells. You may have heard when people get transplants and stuff, their immune system attacks the cells of that sort of foreign organ because the proteins inside of it don't match the sort of the human body, your specific genetics protein code in a way. So your body will completely decide to attack that foreign organ, that foreign protein molecule, etc. And in some people, it does this to capsaicin. Not entirely sure why it does that to capsaicin in a specific amount of people, but I assume that is generally just due to genetics, due to the fact that you may have abused it before, and your body, this is sort of your body's response to saying that, like, we don't want this in our body anymore, in a weird sort of way. But IgE antibodies are the thing that is produced to actually cause the allergic reaction from capsaicin. IgE antibodies are things that act on the capsaicin molecule immediately, and there's other things like IgG, which causes a sort of weird delayed reaction in a way. But IgE antibodies produced by, IgE stands for immunoglobulin E, and these antibodies are produced by things called lymphocytes. They can sort of detect the capsaicin. They'll perceive it as foreign due to the codes inside of the cells themselves that they've been given, that your genetics sort of contain, and this means that it will then go around, it will try to inhibit that capsaicin, kill the capsaicin, even though it isn't really something that's alive at all in a way. But that is kind of how things like food allergies, etc. work. They perceive the things as foreign, and that means that it's going to end up trying to sort of take it down. It's going to do loads of bad things in the process of trying to take it down, because it's so focused on that, it forgets on the other parts of your body that it actually needs to sort of take care of, as well as the fact that the process of taking down capsaicin in these autoimmune reactions can cause a few other bad things for the body as well. But one of the things that happens when capsaicin is detected inside of the body in the people that are allergic to capsaicin is that it will start releasing histamine, which is an inflammatory substance, to try sort of capture and stop the capsaicin from being able to move around inside of the body. You've probably heard of things known as antihistamine sprays, bug sprays, etc. They're sort of when you get a mosquito bite on your hand and it sort of kind of puffs up in a weird sort of way. That is inflammation. That is histamine doing its thing, because there is some sort of probably infection there from the mosquito bite. Maybe it's a few parasites, not as bad as things like malaria, etc. But there will be some kind of immune battle and war happening in the site of that bite, and that is histamine inflaming that site, making it kind of warmer in a weird sort of way for your immune system to be able to actually act on it effectively. But these allergies, this inflammation can cause anaphylaxis, I think, which essentially causes inflammation of your throat, can stop you breathing, which could potentially be incredibly fatal if you don't immediately get medical assistance in that case. And that's why treat capsaicin pretty cautiously if you are going to try it for some sort of maybe weight loss or for some kind of metabolism benefits, simply because it can cause a lot of issues in some people, completely irrelevant and away from the burning and itching sensation which we talked about earlier in the video. But as well as this, now I'm going to get onto the metabolism of capsaicin, what happens to it when it's absorbed through the gut lining. It will go through the esophagus, stomach, duodenum, into the gut, small intestines. That's where it's absorbed into the bloodstream. Capsaicin, like another molecule known as BPA, is fat soluble. It means that it cannot travel around in water. It can't dissolve in water whatsoever. It can only be dissolved in fats, and this means that it cannot be excreted from the body while it is fat soluble, because the way that your urinary process works is that your bloodstream will go through your kidneys, things like glucose and water, urea, etc. They will all osmose out of the kidney tubules and into the bladder. The problem is that fat itself, lipids, are incredibly big molecules because they sort of bind together in a weird sort of way. Blood is mostly made up of water, so you will get the sort of massive fat molecules that are hydrophobic in the middle of the sort of main part of the blood plasma, which is water. But capsaicin will then be able to diffuse into things like liver cells and that's when capsaicin can actually be metabolized. And capsaicin, it has a few sort of pathways. The metabolism of capsaicin is very similar to BPA, but it just has a few more sort of steps that it needs to take to actually be able to be excreted from the body and become more water soluble. Now, the way that the process of metabolism of capsaicin works, as I say, it's similar to BPA in the way that it has phase 1 metabolites and phase 2 metabolites. This metabolic process isn't really linear like some things like glycolysis that I talked about in the past. It's more of a sort of pyramid thing. Capsaicin can be produced into many different molecules that are phase 1 metabolites, and then many more different molecules that are phase 2 metabolites that can all be excreted by the body that are water soluble. But it really just depends on what your body has available to it at a specific point in time. Now, the first step is the phase 1, and that is turning capsaicin into 16-hydroxycapsaicin, 17-hydroxycapsaicin, and this is done by the enzyme cytochrome P450. Now, cytochrome P450, I've mentioned that in the BPA video as well. It isn't an enzyme in itself, it's a category of enzymes, I'm 90% sure, and that's why the cytochrome P450 category can turn capsaicin into specific molecules like the 16, 17, and hydroxycapsaicin. But after you have these 16, 17 hydroxycapsaicins, etc., it is added to a few more molecules known as glycine, glucuronic acid, and sulfate. These are often the main molecules that are added to foreign and potentially toxic substances like BPA. Capsaicin, while it's not toxic, can have acute damage and be allergic, but it's not really toxic or anything. It's not like BPA in the fact that BPA is estrogenic. It can stop fetal development and all that sort of stuff. But capsaicin, because it's quite a foreign molecule, your body's not used to it in a way, it will bind to molecules like glycine, glucuronic acid, and sulfate, and that will make it more water soluble, allow it to travel and dissolve in water in the bloodstream, means that it can immerse and osmose into the kidney tubules with the water and then be excreted in the urine. And while not much is known about capsaicin, which is mostly metabolized inside of liver cells, as the majority of toxic and foreign substances actually are, this is pretty much the best that scientists have been able to come up with during their research, during this sort of tracking of capsaicin, how it ends up turning in stuff in the body, what sort of happens to it in its metabolized forms. But I mentioned the 16 and 17 hydroxycapsaicin. That is the sort of OH group that means that it becomes either 16 hydroxycapsaicin, 17 hydroxycapsaicin. That's why it's alkaline forming, because alkalis are typically things that are hydroxys. They have the hydroxyl group, and that is pretty much it. That is all the things that capsaicin does to the body. There are probably a few things I've missed out. I didn't exactly explain the specific detailed mechanisms of the things that capsaicin does to the ion channels. Like, I don't know the exact part of the molecule that binds to the ion channel, but that's probably quite a complicated process in and of itself, which I'll go through in potentially a separate video later down the line. But with that, I hope you enjoyed this video, and I also recommend subscribing because I love this community of young tribal people who are willing to improve themselves so much more than they already have, and good luck.